Happy Monday, everybody. And we only have one more Monday left in this school year. And so I noticed that 9 of you were sending me and emailing me assignments and doing your work after 10 p.m. last night. So for you, Monday mornings must be rather rough. Or maybe it's rather easy to roll out of bed, but then picking yourself up off the floor is probably another thing. But at least look on the bright side. At least Mondays only happen once a week. You know that Sunday and Monday got in a fight. And you know who won? Sunday. Why? Because Monday is a weekday. And so, make sure you take attendance. This is Monday, May 11th, and this is e-learning. In store for this week, this is Math Counts week, and because if you're involved with that, Math Counts, since our state finals were canceled and there was no opportunity to for the national competition, Math Counts has provided a lot of activities because this would normally be the National Math Counts week. And so if you click on this link, you're going to see a lot of opportunities for this week. And so today, they all occur they call it pie time at 3:14 p.m. And so that's after our e-learning day from 9 to 3. And so Monday, there's some math video challenges if you want to watch those. But Tuesday, they're going to create kind of a countdown round finals from a previous one, and so you might want to check that out. Wednesday, though, is the big day because we're going to do the open Math Count state competition. It'll be unofficial, but there will be prizes, and so that'll be exciting. You have to register, so click on that, register now, and look into that. If you need my help on anything, let me know. And so these are things you can do, and so that's Wednesday. Wednesday's the big day. Thursday, I think you can still finish up things till Thursday afternoon, and then they're going to go over answers. And so Wednesday and Thursday are great days, and then Friday they have some activity in the world's largest countdown round. And so really Monday and Tuesday, but I'll try to remind you of these things as the week goes on for Wednesday, Thursday, and Friday. Okay? And so for this week, we do have new warm-ups. A couple of you are falling behind, not very many of you, but there's 3 new ones. You need to click on those and the logic problems. And the logic problem hints for this week. The first couple. Find 3 numbers, just 3 numbers, that add up to 201. Which 3 of these? Boom, boom, boom. Those 3? Which 3 add up to 201? I sure hope I didn't click on the right 3. I better delete it quick. Oh, you could rewind and then figure out what the answer was. What 3 numbers add up to 222? Just pick 3 sections. Maybe it's this section, and this section, and this one. Well, I know it's not these 3 because this ends in a 0. So, and just highlight them, and you'll get it. Okay? So a couple quick ones there. Then over here, we have plug in the numbers 1 to 9. So you're using each of them once. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. Just use each number once and only once. And we're ignoring order of operations. So for example, if we're going to add 2 numbers and then divide by 2, you're going to, hey, I'm trying to teach. And add 2 numbers and then divide by 2, you're going to add first. And so if you want these to add up to twice this. So if this is a 3, you want these to add up to 6. If this is a 4, you'd want them to add up to 8. If this is a 5, you'd want to add these up to 10. Okay? So there's lots of possibilities, and then you got to make these work down. How do you get to 15? And things like that. Okay? Then down here, you're counting total triangles. What I would do is count them one at a time. 1, 2, 3, 4, 5, 6. There's 6 that are just 1. And then write that somewhere. Now, how if I included 2 at a time? Or 2 sections. There's 1 there. There's 1 there. Here's 2 sections at a time. And then count them 2 at a time. Then you would count them 3 at a time. How many of those? Then you'd count them 4 at a time. And here's a 4 at a time. And then you got this big one, you got a big one, you got quite a few. You count those. Same thing with rectangles. Squares are rectangles, so you count those too. and I would count the 1 at a times. How many 1s are there? And then count them 2 at a time. And then count how many of those, and count the 3 at a times and 4 at a times. And then come up with an organized way of counting those. Now this bottom part here, we did one like this the other week. I think it was 2 weeks ago. You're plugging the numbers 1 to 20 in exactly once, so you might want to write them out. A 1, a 2, a 3, a 4. And 2, it's just factor pairs. 2 numbers multiplied together give you 20. But this problem's different because it has a diagonal. And on that diagonal, I didn't say how many pairs. It just says, so each row and column contain 2 numbers. Didn't say anything about the diagonal. Well, I don't want you to be confused since I'm not there with you. The diagonal only has 1 number, and it's a 20. And so where would this 20 go in order for this all to work? Well, look down here. Which one of these are multiples of 20? Well, there's 2 of them. And so it's either going to go in this column or it's going to go in this column. The 240? Yes, you'd be correct. I'm telling you, this is where the 20 goes. And there's only 1 number, so all these are going to be empty. Okay? And that's my hint. And then the other hints you can use are from before. Okay? When we gave you hints on how to do this before. Okay? So think of the numbers like 19. Go 19 first, look for 19, look for 17, look for 13, look for 11, look for your primes that are higher. Okay, and if you can locate those, then everything else should fall into place. Okay? And then for the last one, move me out of here. For the last one, remove 3 matches so that each equation is correct. And so it doesn't matter, you don't have to write the letters of the matches. I was going to do that, but... And good luck trying to get the other 2. And so, if we look at this last one, 8 times 9 plus 76, does it equal 90 plus 36? No, it doesn't. Well, I got to remove 3 matches. Well, if I remove this one, this would make a 0. 0 times 9 is 0. And 0 plus 76, 76 trombones that lead the big parade. Could I make the other side equal to 76? Yeah. You would just scribble out this one, and you would scribble out this one. And that would be 40 plus 36. And see, you showed me what 3 matches you scribbled out, and you can even show me that you get 76 on both sides. And so there, that one's done. Now you got 2 more. Okay? And you just have to eliminate 3. There's no tricks. It's just eliminate them so you can figure out the answer. Okay? And so, logic problems, many of you have been doing them. I hope you've been enjoying them. And that's a way to raise your grade. And so if your homework, you're getting 10s, 9s, you get an 8 or a 7. It's like, oh, my grade's not good. Just turn in some logic problems. Boom, you're good to go. And so make sure you get those in. And we only have a couple more weeks of these. Okay? So let's go to the notes and see what's in store. For algebra today, we're going to be continuing on with our inequalities. But today we're going to graph them. And so it's going to be a little pre-algebra review with a few algebra things thrown in that we didn't discuss last year, but graphing linear inequalities, we're actually doing 2 sections at once, and then we're going to graph systems, but both of which we touched on last year. And this is going to conclude our inequalities, the greater than and less than discussion. Then we're going to be on to quadratics on Wednesday. And so we have a worksheet, but we also have problems you can do on the back. Page 493, 25 to 33. It doesn't really matter where you do them, just scan them both and make sure I get both pictures. And there's a couple of you that do the assignment up to about the last 2 and you just leave them off. Should I do that? Just kind of stop the video now. I started and I'll just quit. And so we need people growing up to be people who finish things, not just quit early. And so make sure that you do the entire problems. And a couple of you, Judah, you know who you are, just not doing the last couple every time. And so make sure you get them done. I've been noticing. Finish all the problems, okay? And so we got warm-ups this week, get those done, and we already had the logic problems. And so today we're going to talk about, not that, that's out geometries. We're going to talk about graphing systems, and this is notes 124. And so on 124, make sure you write 124 down. You'll remember some of this from pre-algebra and how we graph an inequality. And we used to say, here, y is less than negative 2x plus 1. Well, what sets of ordered pairs? Well, this is an x and this is a y. And remember, if you plugged 1 in, 1 is less than, well, negative 8 times negative 2 would be 16 plus 1 would be 17. And that is a true statement. That is a yes. And so we would graph the point negative 8, 1. And then negative 5, negative 6. Remember, the negative 6 goes in for the y. And when you plug negative 5 in here, that's a positive 10 plus 1 is an 11. And that would be a yes. And so you go left 5, down 6. And then we have the point 7, 9. Well, the 9 goes in for the y, not the x. And so 9, is 9 less than negative 13? Well, that'd be no, so we don't graph that. Well, 0, 8, 8 goes in for the y. Is 8 less than 0 times negative 2, 0 plus 1? Well, that's a no. How if I plug in the point 8, 0? Plug 0 in. 0, is that less than negative 15? Well, that would be a no. Then we plug in negative 10. Is negative 10 less than negative 4 plus 1, negative 3? That would be a yes. A big old capital Y. Left 10, down 3. Well, that guy's right there. And then we plugged in a 2 here. And is 2 less than 5? That's a yes. So negative 2, 2 would be right here. And then we plug in a negative 5 for Y. And negative 5, is that less than 7? And that's a yes. And so these are yeses. And so that was the point left 3, down 5. And then we have the point 1, negative 3. We'll plug the negative 3 in over here. Negative 3 is less than negative 1. And that's a yes. So 1, negative 3. So we have all these yeses. And usually we don't plot the no's. But if we were going to plot the no's today, here's several of them. 7, 9, right? 7, up 9. And hopefully these are all graphed right. And 0, 8 was a no. And 8, 0 would be a no. And remember last year we talked about, do all the yeses and all the no's hang out together? Well, if this is a yes, and 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 my no's are over here, you can kind of see, if I asked you, is this point a yes or no, you'd probably go, well, that's a no, and you'd be right. Is this point a yes or no? That's a no. If I said this one, you'd say that's a no, and that's a no, and you're like, I don't even know why I'm saying it's a yes or no, but I've done a lot of math, and I got good intuition. And if I said, is this a yes? And you go, yeah, that's a yes, and that's a yes, and that's a yes, and that's a yes. But then it's like, well, what's really separating the yeses from the no's? What's that? Jacob? Oh, yeah, the line is separating the yeses from the no's. And so if we graph this line right here, that is y equals less than negative 2x plus 1. If this is my m and this is my b, we're going to begin at 1. And if my slope is negative 2, how are we going to graph that, Cody? Yes, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And then, oh no, I got to remember this. If it's y is less than, would that have been an open dot or a closed dot? Oh yeah, they've been an open dot. So remember what we did? If it was an open dot, if we had this symbol, less than or greater than, if it was an open dot, we would use a dashed line. Wake up the echoes, dun 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 dun. Remember, if it was a closed dot, we're going to graph a solid line. And so that's going to be less than or equal to and greater than or equal to. And so this is going to be a dashed line. And so I got a pretty cool tool here that can quickly make me a dashed line. And this line separates the yeses from the no's. And how I wish it was just like last year. I could run around with my marker going, Boom, 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 boom. And here's infinitely many points, and infinitely many points, and infinitely many points, and infinitely many points. And then where are the yeses? Boom, 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 boom. And some of you tried to hide your paper from me, and you don't want me marking on your paper. Well, guess what? Mark on your paper. And so how many points are these? And points between points. But wait, I got this. We can go quicker. And points between points, 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 and points between points. Do you think this is pointless? Points between points, and points between points, and points between points, and points between points, and points between. It would just be easier to like shade it because we could never graph an infinite amount of points. And why are we graphing? To show the infinite amount of solutions to this inequality. And if you don't get the point, we're going to plot infinitely many points on your paper to understand that we are plotting infinitely many solutions to this inequality. But is there a faster way? If you read that to me, Logan, it would be y is less than. Yes, remember when it's less than, we shade below the line. And so if we move me up here, I'll get under. Well, that's cool. I'm under the writing, but over the paper. I'm kind of in between. And so remember, we're going to shade or color or whatever you want, the appropriate region. And remember, we shade below the line if it's the ground. If we were coloring the ground, we shade below. And the ground is less than or equal to. And remember, we shade above if we were coloring the sky because it's greater than or equal to. And testing the point is the step that every teacher wants you to do, but you never do. And so like if I tested 0, 0, it'd be a yes because I colored it on this problem. And remember, the dashed line, the line itself is a no. So if we want to include the line with the no's, we make it dashed. If we want to include the line with the solutions, the yeses, we color it in just like we color in the solutions. But it is the boundary, the great barrier between the yeses and the nos. Okay? And so let's look at a couple more examples and then we'll do harder ones. In pre-algebra, you know, if you look at theirs, we're doing similar things. It's the end of the year and we were graphing. But they get them all pre-made like this because they got the pre. And so they have m is 1/3 and b is -2. And everything's nice in slope-intercept form. And so you begin at -2, and your slope is rise 1, run 3, rise 1, run 3. But remember, would this line be solid or dashed? Danielle, how do we know? Would this be a closed dot or an open dot? Yes, it'd be closed, so that means we're going to have a solid line. Nothing like getting in my way, Kaya. Teaching. And so she just wants to look out the window and see what's going on in the world. That's what some of us want to know, what's going on in the world, but we're stuck inside. And so y is less than, and so are we going to color above or below? Read it to me, Danielle. Y is less than, so we color the ground. And make sure I can see it when you scan it and everything, that we have all that. Okay? Now, let's graph the next one. Well, in pre-algebra, we didn't give them to you in standard form, ax plus by equals c. And for those of you that are going to do the shortcut, and you're like, any equation in standard form, the slope is the opposite of a over b, and the y-intercept is c over b. Oh yeah, remember all that? Whoa, that test, don't remind me. It's a good thing we don't have tests now. And so you could quickly do the slope is -1 over -4, which is 1/4. And you could simply do -12 over -4, which would be 3. But the problem with this is, if you start at 3 and you rise 1, run 4, and you rise 1, run 4, you haven't messed up yet. You look at the symbol. The symbol says dashed line, because it would have been an open dot. And so we got the dashed line going. And that didn't make a mistake yet. But what mistake are you going to make if you just read this and say y is less than and then color below? Why is that wrong? Because it has to be solved for y. And when you solve for y, what's going to happen? Oh yeah, we're going to have to flip the sign. So on these, it's good maybe to show the steps. Subtract x from each side, and you get -4y is less than -12 minus x, which is identity property plus negative 1x. And then when you divide both sides by negative 4, we are dividing both sides by a negative, dividing both sides by a negative. We must reverse the sign because we just oopsed and goofed it up. And so we'd have y is greater than 3 plus 1/4 x. Well, notice we got the right m and b by using the shortcut of the opposite of a over b and c over b. But if you're not paying attention, if that y term has a negative in front of it, you need to be graphing y is greater than. And so we're going to be coloring the sky. Now, that's the section we're skipping, because what we're going to do is put two solutions on top of each other and color the overlap darker, okay? And so let's take a look at the last two problems on the notes before we go to the homework. If we look at this, we subtract x from each side, and we get y is less than or equal to 6 plus negative 1x. And we'd like to see that on your paper. Either how you figured out that the slope was negative 1 and the b is 6. Well, if the b is 6 and then we have a slope of negative 1, we're going down 1, run 1, down 1, run 1, down 1, run 1. Would this be solid or dashed? Ethan? Yes, solid. And so I don't have the color right. Oh, well. And so that is a solid line. And are we going above or below that? Abby, read that to me right there. Y is less than or equal to. So we're going to go below. Now, when we're putting two on the same graph, you might want to just color it lightly, so you're keeping track of where the yeses to this one are. And then you want to graph the next one. Divide by 2. And we get y is greater than 1/2 x plus what, Cam? Yeah, plus 0. And so my m is 1/2 and my b is 0. And so I'm going to begin at 0. I'm going to go rise 1, run 2. Now before we just wanted to know where the lines cross. Well, now it's going to be where do the regions overlap. Is this graph solid or dashed? Judah. Why? It'd be an open dot, right? So it'd be dashed. Great job. And so this one is going to be dashed. Now are we going above or below this line? Y is, read it to me. What would it be, Joe? Y is greater. So that's going to be the sky. And so we're going to be above this one. Well, the thing is, you can color them both lightly, but the solution is actually the overlap. And so these are the yeses to both. Now remember, if you're on a solid line next to the region, the line is included as a yes. But if you're on a dashed line next to a region, that line itself is a no. It's just a border. And so the line is included, we color it like we color the region. If the line is dashed, that's trying to show that it belongs with the part we don't color. Okay? And then for this second example, we have the absolute value of x plus 1 is less than 2. Where are all the values of x in the coordinate plane? We already did one like this the other day, except now it's in 2 dimensions instead of 1 dimension. Well, remember, absolute value, if it is a less than, Madison, it's going to graph land. Less than and makes land. And so remember, we broke this apart. X plus 1 is less than 2. And at the same time, then we do a little double switch. X plus 1 is greater than negative 2. And so we solve this one right here. We get x is less than 1. And we're going to graph this one, subtract 1 from each side. We would get x is greater than negative 2. Are these horizontal lines or vertical lines, Preston? Yes, they're vertical lines because remember the x equals are always vertical, and these are both dashed. And so we have a vertical line at x equals 1. And we have a vertical line at x equals negative 2. Now if these shift over, they're going to be in the wrong spot. Yeah, I figured. And so x equals 1 and x equals negative 2. Well, we are going, how do you go below an x equals 1? Well, you don't go below. You go to the left. And so you're going to the left of that one because that's where the x values are less. How do you go above an x equals -2? Well, you go to the right. So you could go below this one, which means you go to the left. And then you go to the right of this one. But then we only want the overlap. And so just like when we're graphing, the overlap makes land. That is really the solution. And a simple Atari game that I had growing up, that's how we got a road. The simple computer program would just be less than this, greater than this. Look, I made a road! And it was so exciting. Nothing compared to Xbox 5000 or whatever, but it was cool for us. A little nostalgia, okay? And so we can take a look at the last examples on the notes. And so that was it. Now let's take a look at the homework. So on the homework today, you want to, we don't need to do the ones that are solved for y. Boy, getting dizzy as I scroll up and down. And so remember on problem number 2, the m's are 0. And the b's are 3 and -3. These are going to be horizontal lines, okay? Remember, this one is backwards, trying to trick you. So your m is 1 and your b is 0, but you're going above the line. You're going to color above because I wrote it backwards to try to trick you. This one is going to be a vertical line. And so there is no slope. And there is no y-intercept because that one is a vertical line. X equals greater than 4. And so you're going to color to the right of it. Okay? On the bottom part, this one, remember when you find the m and the b, you're going to actually have to flip the negative sign. Flip the inequality sign because you're dividing by a negative. This one, you're going to divide by a negative. So you think you're coloring above, but you're really coloring below. This one, you divide by a negative. This one, you divide by a negative. You're going to flip the sign. This one, you're dividing by a negative. You're going to flip the sign. That next one, you're not. So you're not going to flip the sign. Problem 7 together. Of course, on these, you could solve them each for y by subtracting 3x from each side and then dividing by -1. Oh, yeah, and then I'm going to have to flip the sign. But if you want to use the shortcut, remember the slope is the opposite of a over b. So that'd be -3 over -1, which is +3. And remember, the y-intercept is c over b. And so -1 over -1 is +1. And so we're going to start at 1. And then we're going to rise 3, run 1, rise 3, run 1. Is this line going to be solid or dashed? It's going to be dashed. And so, but then the thing is, if you don't actually solve for y, you have to remember that we are flipping the sign because you would divide by a -1. When you divide both sides by a -1, we're going to be below the line. And so we are here below this line. And if you color the wrong side, you'll be printing yourself another worksheet because you'll be like, I messed this whole thing up. And so on this one, if this is 1 and this is, I should change colors. If this is 1 and this is plus -1, well, it's the opposite of a over b, so that's 1. -4 over -1 is 4. And so we start at 4, and then we rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. And so this is going to be solid or dashed. Well, this will also be dashed. But then the thing is, on this one also, to solve it, we would have divided by a negative. You have to flip the sign. So this is also going to be below. And so if we go below on this one, we're below on both. Well, where is the overlap? Bree? Yes, the overlap would just be down here in this corner. And so that's the yes to both. Okay? And so you have a little, no stickers today, so a little smiley face. Great job. Now, you finish the front side, and then on the back or another piece of paper, just make sure you scan them both. Is some questions where I give you the answer and you write the problem. So, Colin, this is right up your alley. You don't have to show any work. Just write the answer. And so if we write this, we have y equals mx plus b. Well, what is your m and the b of this line? Well, if it's horizontal, your m is, who's trying to access this computer? M is, and so we have m is 0. And then we have a b of -1. And so we would just have y. Now, did we color above or below? We colored Mason above, so it's greater than 0x plus -1, or just greater than -1. Do we need a line underneath? No, because it is a dash line, so it'd simply be y is greater than -1. For 26, if it's vertical, Jordan, it's going to be, yeah, x. And if we're to the left, is that greater than or less than, Elizabeth? It's going to be less than. And so this is just x is less than 2. Wait, oh wait, Mr. Nice, you almost made a mistake. Just seeing if you're paying attention. What is that, Annabelle? Yeah, we would need a line underneath because it's a solid line. So it's x is less than or equal to 2. Now for these last ones, you got to figure out where the dots are. And so on these, there is a dot at the B, and then this dot's right there. Here there's a dot, and then this dot isn't until there. This one has a dot here, and then the next dot's right there. And so some of them don't line up very well. And so if we look at down here, there's a dot here, and these dots. We're just trying to help you out since we're not here with you. And then you get to these last ones, knowing where the dots are. There's a dot here, and then these dots are right there. These dots are easier to see. And this one's a little tougher, but they're like that. Okay, so then it should be pretty self-explanatory. Okay, so I know all of you do a great job. A little pre-algebra review, but this is really algebra and getting you ready for always the next step. And so write all these down. Send me your homework right away. Work on your logic. Get your warm-ups done. And email me any of your questions. And remember, it is Math Counts Week, and so at 3:14, every day there'll be an activity. Wednesday is going to begin the big days. But you might have to make sure you can get your account on AOPS to do that. So, hey, have a great day. We miss all you guys. Keep up the good work and finish to the last problem. Judah, it's you. And so finish all of them, not just always quitting early. Okay? Bye-bye.